Hi, I'm Leah. You might know me under the username or under Layton or the username Ultraviolet. I do various Fedora adjacent things, but this presentation's not gonna. It's gonna be Fedora related, but it's about our downstream distribution, Ultramarine.
Hey, I'm Jaden. I'm the CEO at Fedora Labs, and I work pretty heavily on Ultramarine. Uh, Owen.
Yeah. Hi, I'm Owen. I'm the hardware operations manager at Fedora Labs, which involves all of the fun Chromebook stuff that we do. And I also just do general business and community stuff.
Hi, I'm June. I do some packaging for our Terra repository, and with Chromebooks, I've started working on kernels for the packaging kernels for the ARM Chromebooks.
I'll introduce this part. I'm our downstream distribution, Ultramarine, which is essentially desktop spin of Fedora. It's derivative, and essentially the goal is to build something that we could get, somebody who hasn't used Linux before to use feasibly, right? So we modify a lot of Fedora defaults. We add in a lot of packages that we believe are missing from Fedora, and there's some other stuff. However, this presentation is not about, sort of the intricacies of what we add into Ultramarine, but rather sort of what our relationship looks like with Upstream and how we run our project, and sort of notes of what we think Fedora could learn.
Here's our agenda. We're going to go over values, the point of this, our experience being downstream, our current development stack, the repository we call Terra, a little section about our neighbors, shout out Noel, some strange hardware that we work with, and then talk about how you can get involved. And we're going to start with our values and philosophy. Ultramarine is built around a set of values. We have 4 of them. We phrase them kind of as statements. Ultramarine is pragmatic, progressive, user-friendly, and accessible. We like to tell a little story. Sometimes people who are getting started with Fedora, they install it, and I've done this myself, don't know where all the packages are. So they install Snapd or do something weird. I did that back like 7 years ago now. And it's kind of hard to figure, I need RPM Fusion and I need this and this and this to get my system up and running. So we work off the model of least resistance, and we include RPM Fusion and some proprietary software like NVIDIA drivers and a couple other things just to get you off the ground. We're progressive, so our goal is to pick up new technologies when they can improve the user experience. So we ship stuff like DNF5 we switched to in Ultramarine 40 before Fedora got it. We use systemd repart pretty heavily now in the Raspberry Pi images we'll cover later, and our new installer. We're user-friendly, so we do a couple desktop tweaks, some shell tweaks, just to make things a little bit more rounded out, a little bit nicer out of the box. And we're accessible, so we have easier on-ramps for developers. We're pretty heavy on GitHub, and we utilize the pull request workflow, so it's easier for developers to get onto Ultramarine, and we also do hardware compatibility for that accessibility.
Okay. Sort of our main, sorry. Our main goals of we have 3 main goals of Ultramarine, of what we want it to be. Progressive platform, so we want to have a place where we can experiment with new technologies to develop them, and sort of learn from the successes and failures of other platforms. We want to be a friendly Linux desktop, as I mentioned before, friendly as in technology, but also our community, which we've fostered over a while, and I would say is pretty good. And then base of Tau. Tau is another project that we have. It's a experimental version of Ultramarine. It is built on the idea of continuity and just continuity and integration. And I know those are vague words. To basically describe it, we have like integration with a custom daemon that allows you to basically sync your application configs between different Tau devices and such. I don't have time to go into all the details of Tau, but the point being is that it's just an experimental derivative of Ultramarine. Okay.
We like to say it is easy being downstream. Fedora is a really excellent upstream, and we want to talk about why. So the reasons that we chose Fedora are release cadence. You guys release every 6 months. Each release is supported for a year, and it lines up really nicely with some other upstreams like GNOME and KDE. So every release, we're getting a new desktop, and things feel fresh for users. And if the user doesn't want to upgrade, they are totally able to and stay for a year, or stay for an additional 6 months after that. Progressivism is also another big factor of why Fedora. You guys adopt new technologies faster, like Systemd. You were the first distribution to do this. This allows us to be at the forefront and push a little bit further ahead. Quality. Fedora releases and the software in them, like DNF, all that stuff, is just really well made. It's just good stuff. And ecosystem's choice, a lot of development does happen on Fedora. Stuff like the kernel is built on Fedora, so I think it's a pretty good choice for that. And we also think Fedora is incredibly friendly. We've worked heavily with you guys. Joseph, for example. Oh, yeah, please. This works if you're trying to like pitch Fedora to your boss at, yeah. Fedora is incredibly friendly. We work kind of heavily with Upstream. Here, there's a picture of us. We did a panel with Matthew at Scale. And the people involved in Fedora are the strongest factor in it. We've had lovely conversations with everybody. People from Neil and Matthew to people like Joseph, who just showed up one day and was like, hey, we want to get a relationship with you guys. So we really appreciate the stuff that Fedora does. They even sent us a Valentine. It's a really nice little relationship.
Okay, so we'll just have an overview of our stack, which is just the way we build things and sort of how we deviate from Fedora. Okay, so our stack includes everything. So we're going to talk about programming languages and our tools, but we're also going to talk about things that you might not consider a part of a tech stack, such as the people and sort of the collaboration that we do. Okay, so our primary community hub is on Discord. Yes. Let me explain. Yeah. Okay, so our primary community is on Discord, and our sort of the reason why we chose Discord over like a traditional forum or a mailing list or Matrix, for example, is because it has, besides the fact that it's sort of gained a lot of traction in other open source projects, right? We find it as a very easy to onboard place for new users and contributors, especially in the sense that it's real time, which helps a lot. We also bridge our Discord to Matrix, albeit the bridge is used sparingly, as far as I know.
I think we maybe have 10 users.
10 users of the bridge. And it's not just discussions about code contributions or products. It's just a community where people just have fun. And we also have a lot of custom workflows in our Discord, which through our custom bot, which
We have a custom bot that handles reminders and a couple other things. We have a system where you can talk about what you did in the day and it'll post in a public channel for people. We also have an integration with our project management tool that will be mentioned.
yeah, so for project management, we use a tool called Linear. I'm not sure if any of you are familiar with it. It's sort of a newer tool. And it's sort of like GitHub Issues, but you sort of on steroids, you could say. And it's there are some difficulties with it. I sort of it was sort of designed for, I guess you could sort of call them like the traditional Silicon Valley type startups, where you sort of have like 5 engineers working in a team or such, and it's like closed source products, which in a sort of a project where you have like free association, right? It doesn't. There's a bit of a mismatch there. However, there are workarounds. So we do have bidirectional sync with GitHub Issues, which we use extensively. And then we basically add anybody to our linear plan, who wants it, if they contribute. And regardless of all this, it's an amazing tool. I think you should check it out if you have the time.
Yeah, as someone, I've worked project management in like normal corporations, and I think the linear method is the only one we've tried that engineers don't actively hate. Like, we've tried Agile, we've tried all of that stuff, and engineers just don't seem to like it for reasons that we don't have to get into. But it seems that the linear method is the only one that they truly don't hate.
Yeah. Or rather, it's the one that I hate the least. Okay. let's talk about our actual toolchain. So we've replaced a lot of the Fedora toolchain with our own components. Two of what I'll be talking about right now is Onda and Subatomic. Onda is essentially, it's a meta build system, which in reality just means it allows you to have a mono repository of spec files, right? And it just makes it easy to manage all of those. Subatomic is a repository server, I think, similar to, I think it's called Pulp, the Red Hat thing, which it's really simple. You can just upload RPMs. It manages signing and repositories and such. Yeah, that's all. We also have developed a custom image builder to replace Lorax for our use case. So our tool is called Katsu. It's different from Lorax. Rather than taking in a sort of a kickstart file, it takes in a YAML file with a list of packages, which for a specific builder, in this case DNF. In the future, we're going to support other builders for other distributions, but right now it's just DNF. And it also gives you an easy way to basically define a disk layout. It also supports building to OCI images, just a tarball if you want, and bootable ISO.
Before I worked on Ultramarine, I worked on Rizzy and Rizzy OS, and we stuck really close to the Fedora toolchain. We used Lorax, Koji, all that stuff. And as someone who did that, Katsu is a lot easier to configure. You just get one little yes.
Sorry, you're going to wait until we finish your sentence.
You get one nice file that can call back to others to compose your ISO image, and you don't have to go through the pain of writing a kickstart and feeding it into Lorax and all that.
I was going to ask, have you looked at Kiwi?
Have we?
Yes, we have looked at Kiwi. We found, I haven't personally, but I know some other people in the community have, and they've sort of found it a bit hard to work with and a bit complex. Katsu is sort of our solution to that.
It's a little bit easier.
Yeah, or at least we think so. We're primarily a Rust shop. We also have some other projects like in TypeScript, Nim, Go, Vala. For example, Onda is written in Rust, Katsu is also written in Rust, Subatomic's in Go, and we also just have various web services in TypeScript, such as, I think it's called Tetsuda, which is a lightweight replacement for Mirror Manager, which runs on Cloudflare Workers, which is, to describe it, it's like Cloudflare's sort of edge compute platform. We serve a lot of packages. So right now, we also have a lot of infrastructure for our contributor needs. So for example, we run a WebLate instance for handling translations. We currently rent out Dedis from a Hetzner, basically, and we just have them running in a Kubernetes cluster. We also take advantage of Cloudflare Workers and other serverless options when they do make sense. For example, Tetsudo, which is the Mirror Management replacement I was talking about before. Yeah. We use GitHub a lot. So we use GitHub Actions to basically build images. We build packages for GitHub, and it works pretty decently. Rather than using like an external build system or external build server like Koji or such. However, GitHub Actions can be frustrating at times, but we have a lot of hacks and workarounds to make it work for us. And in general, I would say that it's a pretty good user experience. Like for example, you can just make a pull request to your repository. It will build. It will run checks against it. Everything. The nice thing about GitHub Actions is that it's extremely transparent, right? So everybody can easily look at a build, look at the logs, see if there's anything wrong. Oh yeah, sure.
One funny thing about using GitHub Actions for something like building ISOs is that if you download an Ultramarine ISO directly out of CI, sometimes it comes from Windows.net, which is just a little funny.
So you might notice we work with quite a bit of proprietary software, for example, Discord and GitHub, right? And I know there's a lot of people who probably have an objection to that, but here's sort of our rationale. Cost, right? So for example, GitHub subsidizes us a lot in terms of CI. right? I'm very grateful to them. Also grateful to,
They haven't shut us down yet.
yeah. Also very grateful to Works on ARM, I think that's it. Yeah, who has basically sponsored a really powerful ARM server.
I think we have 96 cores in that thing.
And like,
We use it to build the Pi images that you might have used or seen recently.
yeah.
We'll get into that.
Yeah. A lot of FOSS has sort of a reputation for bad UX, and while a lot of that is, I guess, from older software, right? There are some examples, right? Like maybe I'm the only one, but I do know a lot of people have frustrations with using Matrix, especially because last night I almost got basically locked out of my hotel room because of Matrix. So that was yeah. That's a story for another time, though. Accessibility, we want to use tools. We want to bring in as many contributors as possible. That means using tools that are, well known, rather than something that's a bit more niche. And pragmatism, we believe that FOSS is the end game. However, we want to use the best tools we can and that are available in order to get there. Hello, Jim.
All right, so a terrifying repository, our repository that we package a lot of extra things in is called Terra. So what is Terra? It's a community-driven RPM repo with a fairly low barrier to entry for new contributors. As Leah kind of talked about, using GitHub helps make that easier for new contributors. So it's somewhat similar to the AUR in that it has a lot of extra packages that the main repos don't, and it's fairly simple to package for. The tools that we use, like Leah mentioned, Onda, is a little bit more similar to the Arch make package tool than it is to fedpkg or something like that. And also Terra itself is a monorepo of a bunch of different spec files, which is structured a little bit more like Nix packages, but yeah. So Terra contains binary packages, which not source-based because RPMs, which is another difference from AUR. And in general, it sort of feels like a middle ground between just writing AUR packages for Arch and standard Fedora packages. And why am I talking about Arch so much, and why am I here? So I came to Linux, the first Linux distro that I daily drove, and probably the one I used for the longest was Arch. So part of the reason I stuck with it for a while was because writing Arch packages was so easy for me. And when Leah tried to get me to use Fedora and eventually Ultramarine, I tried it once, and then I just could not figure out RPM packaging, so I kind of gave up on it for a while. And then I tried, packaging it the way we do in Terra, or packaging RPMs the way we do in Terra, and I found it a lot more intuitive because of the similarities more so to Arch. So more specifically, how do we package things in Terra? So Leah mentioned Onda. Basically, the way it works is there's just a mono repo similar to Nix packages where there's a whole bunch of RPM spec files, and then you can just call Onda as a CLI tool and pass in the directory to the spec, and then it builds. It's a wraparound mock, so it builds in mock. We use GitHub for code hosting and CI, and we do auto updates using Rye scripts. So Rye is a scripting language that embeds easily into Rust, and Onda's written in Rust, so that works. The update scripts are usually very simple. Oftentimes it'll be literally a single line, because if a tool is, for example, just comes from a Git repo directly, or a GitHub repo or something like that, we have a pre-written function that just handles the auto updates from GitHub. So the update script could literally just be a call to that function, and that's it. Yeah.
All right, let's talk a little bit about our neighbors. So first, I'm going to pass this off to Leah to talk about XR.
Yeah, so we've been doing a lot of work in the FOSS XR scene as of recent. And I guess for a quick introduction for XR, it's an umbrella term for augmented reality, virtual reality, and mixed reality. Why XR? I mean, it allows you to emulate physical objects in the virtual. It can also have a lot of practical implications, especially in healthcare. For example, XR has been used in physical therapy, right? And also in other professional applications. Why FOSS XR specifically, though? Besides, the typical open source stuff, a lot of the current proprietary XR platforms heavily lock down their APIs and basically make it hard to discover new use cases for XR before their use case is even worth locking down. For example, the Apple Vision Pro, which is a thing, actively prevents multitasking due to requiring immersive mode, which essentially takes full control of the operating system for many APIs, such as full hand gestures and interaction with the real world, such as object detection. Okay. We've been working with a project called Stardust XR. And it's an open ecosystem and display server which acts as both a Wayland compositor and also uses its own protocol. It essentially it composes 2D applications, as Wayland, as I said before, but also OpenXR applications and other virtual objects together. So we've been building a variant of Ultramarine with Stardust out of the box, and we are currently working with hardware vendors to get that shipped. At least one, and I don't think I'm allowed to.
We're not at liberty.
We're not yet. Not today.
Yeah, I'm pretty excited to see where our XR stuff goes. So now let's talk about Ultramarine flavored Pi. So we worked with the Raspberry Pi Foundation to enable Ultramarine Linux support in the Pi Foundation's official Imager application on desktop and Raspberry Pi firmware. So what this is, you can kind of think of it like Balena Etcher, but a little bit more advanced, where it's an app that you can just get on Linux, macOS, Windows, and you'd pick like an operating system or a tool, and then it will image your SD card or USB stick to work on a Pi. But it's also in some Raspberry Pi firmware, so all you need to do to install Ultramarine onto a Raspberry Pi is just plug in an Ethernet cable and an SD card, and then boot to the firmware and image your SD card.
It takes like 2 minutes. It's really
Yeah, it's really fun. I'll talk more about the technical details soon. And of course, there's more than just 2 partners that we have, but unfortunately, we don't have time to cover them all, but we'd still like to mention our wonderful partners and neighbors here, from development and distribution partners to even a Downstream. We greatly appreciate what we've been able to do with all these. So thank you to the Ultrabook Project, Universal Blue, Fedora, GNOME, Sodalite, Free Desktop, and Phosphorns. Okay, it's hardware time now. So, as we all know, Linux users have been making Linux run on weird hardware since 1991. So first, let's talk about Chromebooks. So you may be thinking, why Chromebooks? Why do we talk about Chromebooks all the time? What's cool about them? So recently, Chromebooks have become very popular, and they're also just seen as nothing more than a cheap, glorified browsing machine. And while that may be true, you can do so much more with these devices if you just have some spare time. And you can turn them into a low-cost and, in my opinion, really fun-to-use device that can actually get real work done. So before we talk about what we're doing with Chromebooks, let's talk about what else is out there in the Linux on Chromebook world. So first, a lot of the more technical people are probably familiar with this one, is the full core boot method. So this turns your Chromebook into a standard, almost standard UEFI laptop. And it allows for Windows or standard Linux or sometimes even Mac OS if you're brave. And you get no more Google firmware, and it's completely gone. But you do have a risk of bricking. I did brick a Chromebox of mine once, so that was kind of sad. But there's a risk of bricking, and it also requires modifying the device. Usually you have to open up the device and modify the hardware. So there's also Crostini, which is the Linux environment inside of Chrome OS. So this enables the Linux container inside a virtual machine inside of Chrome OS. And it's officially supported, and it's really convenient, especially for Chrome OS development work. But graphical Linux apps could be better, and it has limited resources and options, and it's also just not that customizable. And since it is a container in a virtual machine in Chrome OS, you don't really have the best hardware.
You're limited to 400 megabytes of RAM. No matter what you do, no matter how much RAM your Chromebook has, you get 400 megs in the Linux container.
I believe it actually depends on the device that you have.
I ran it on an 8 gig model, and I got 400 megs.
I think it scales with your RAM, but I'm not actually sure. But there's other kernel trickery out there, so I'll talk about how this works soon. But using the kernel partition as our Lord and Savior Google intended, so there's no modification of the device needed to do this, and there's pretty much no risk of bricking, but it needs different builds per Chromebook board, and it's pretty hard to jam a kernel into such a small space. Okay, presenting Chromebook edition. So first, let's talk about Submarine. So the way those other kernel tricks work is that when you boot a Chromebook and you target, so when you turn on developer mode on a Chromebook, you can pick what disk you want to boot to. Otherwise, it will just boot to the internal disk. But whatever disk you target to boot to, it scans that disk's partition for it scans the disk partitions for a partition flagged as a Chrome OS kernel, and then it finds it and it boots whatever code is inside of that partition, but it doesn't check if that code is like a valid Chrome OS kernel or not, which is where we come in. So other distributions will jam their kernel inside of that usually pretty small partition and try to make it work, but it's device specific and it requires somewhat extensive documentation to get that to work. But with Submarine, we just put a bootloader inside of that partition. So we get all of the pros of kernel trickery with none of the cons. So what this means is that we can have universal Chromebook images. So we just have like an installer for with Submarine on it, or just Submarine in general on a USB stick, and it will just boot on pretty much any x86 Chromebook made past like 2014, I believe. And let's talk about user space. So most distributions, to no fault of their own, aren't that well optimized to run on Chromebooks, and so they leave things like audio and the keyboard broken, which need scripts after installation to get set up and working. But with Ultramarine Chromebook Edition, we will have a kernel space and user space change to enable audio out of the box on as many devices as possible. And there's also a script built in to remap the keyboard for you. We also ran into a lot of problems trying to get Anaconda to actually work with Submarine properly and try to install to a Chromebook how we want with a very weird partition layout. And we just couldn't really get it to work. So we were planning on making our own installer for all of Ultramarine images anyway, but we started work on the installer for Chromebook Edition specifically, and we call it ReadyMade, and it's built on the back, or it uses systemd repart as the back end, and it's been pretty good so far. We're almost done with it, and right now it just has the basic functionality of just installing onto a Chromebook and doing it really well. But in the future, this will have more advanced options such as custom partition layouts and file systems and stuff like that. One more user space change I want to mention is we use something called F2FS, or Flash Friendly File System. And this is just a file system that works very well on NAND, and it just prolongs the life as much as it possibly can. So most Chromebooks have eMMC or UFS storage, which is like the worst kind of NAND you could possibly have. So we try to prolong the life of these not that good NAND in Chromebooks as long as we can. We also have a Just Works experience. So as I mentioned, while other methods are complex and hard to install, Ultramarine Chromebook will be very easy. So I will now tell you how to install Ultramarine Chromebook onto a Chromebook. So first you just make the installer, and then you enable developer mode and USB boot, and then you boot to the installer, and then you just follow the prompts, and that's it. It's the world's easiest way to install Linux onto a Chromebook.
Not even a marketing service, just
Yeah, that's just an objective fact. So Chromebooks are...
Yep. Nova, which is behind the Stardust XR project I was mentioning before. Matthew from Fedora, yeah, obviously, who actually invited us here in the first place, and also thinks that I'm a VTuber apparently, so. Yeah, and Joseph, of course, yeah. And Addison, who's in the audience right now, helped with a lot of slide review. Anyways, even more thanks to our entire community, CH Ultrabook once again, and Fedora for being an amazing upstream, as well as everybody else. If there's any questions, we'll take those now.
Anything? Anyone? Questions? Yes.
Captured because I saw something that apparently the stream died.
Oh, that's not good.
Oh, it's back up? Oh, okay. Okay, great.
Okay. Go on.
Well, so the question I had was, maybe I missed this because I know there was the mention of core boot and what have you, but one of the reasons why I like Chromebooks is because of verified boot and how that's different from secure boot. When you install Linux with Submarine, is verified boot still a thing, or is it something you're like sidestepping?
So for this, we have to sidestep verified boot. We do enable developer mode, so we don't have Google signing keys, so we can't really use verified boot. In the future, we could potentially have a way for you to modify your Chromebook firmware and put our keys in there, but as of now, we don't have verified boot turned on. Anyone else? Questions? Yeah, Noel.
Hi. So selfish little plug here, but I am from the Universal Blue Project. I'm curious how things are going for you guys as far as considering atomic-based images for your project.
Okay. I guess I'll speak on this one. So yes, we have been considering Atomic for a while, and we do have a lot of ideas of how we want to do this. However, when it comes to Atomic, we do expect it to eventually, not eventually, but soon to supersede our existing mutable images. Being said, though, we do want to take the time to make sure that it sort of matches users' expectation, especially because one of Ultrarine's major selling points is that it's just easy to use. It doesn't get in your way, right? We want to make sure we get it right before we ship any Atomic variant.
Anybody else? Anyone back there? No questions? All right. Per usual, you can just hit us in the halls. We are going to be around all 6 days of Flock and at the Niagara trip. So feel free to see us in the halls.
Also, if you would like a Submarine Chromebook live demo, I will now do that.
In the hall.
Well, actually,
We have time in here.
I'll do it. Okay.
Do you want to just plug it in? Actually, do we have HDMI out here?
Oh, I forgot to mention, but this entire presentation is being given off of Ultramarine Chromebook.
Actually, we can even do the demo on this Chromebook if you'd like.
I don't know if this will.
I don't think it will initiate.
I am, and I don't know
It's
if
done.
it will display out through HDMI.
Well, we can try.
Sure. And if not, I have 3 other Chromebooks with me.
He only brought Chromebooks.
Yeah, I did. I was like, you know, it would be funny if I just brought Chromebooks to Flock. And I also have 4 of them because
All right.
you can never have enough. Yeah, it's not
Yeah.
Oh, it actually appeared up there. That was the
Okay.
developer mode screen. We're not getting you root, but
No.
here.
Oh, there it is.
Oh, actually, there we go.
So here's Submarine right here. You can pick different kernels as well as reboot the Linux shell. And then if you have another installer plugged in, you can pick that as well.
We're working on a graphical interface for this. This is currently in 14 megabytes. We need to stay under 16 though. So let's boot into number 1 here.
It also automatically boots into the first option if you don't touch anything.
I touched things so we could show it up.
Yeah.
That
But
was-
theoretically, you could just turn your Chromebook on, and then eventually it would boot. to
01 was
Ultramarine
right,
on its
right?
own.
01 was the right one, right?
Yeah.
Well, it should be turning on.
It takes a second to initialize.
The live demo guys don't like us today.
We tempted fate, guys.
Let's try this. Oh,
Oh,
here it goes.
what's your password?
You know, it's just.
Really? This is your encryption password too?
Don't. Why would you say that on stage?
You hurt me, Owen.
Let the whole world know.
Okay, but
Yeah, this might take a little. Oh,
There.
there.
we're already at GDM.
Also,
Oh, they beep.
Chromebooks like to beep. It's
There we
mad
are.
at me because I haven't done it.
We're back in Ultramarine. That took like a minute.
Yeah. I'll also mention how insanely fast this boot process was. Even like a $5,000 gaming PC will boot up just as fast as this $200 used Chromebook did. And I have a ton of like really old, kind of disgusting free Chromebooks I got that you press reboot and it restarts just immediately. And it goes to the firmware page in like 5 to 10 seconds.
I blame System D.
Yeah, it doesn't really show that's a Google platform.
Oh, it doesn't show it's a Google platform. This one's unique.
This one has very interesting EC.
This is just a latitude, or not a latitude.
Yeah.
It is a latitude.
This is
It
just a
uses
latitude in disguise.
Dell latitude EC.
You want to swap it?
Let's swap it for the RHEL one here. We have a,
Oh yeah, so we have RHEL on a Chromebook.
This isn't a HDMI.
well, here, we have a RHEL on a Chromebook here. I think this is probably the first time it's been done. It's,
No, Leah did it before me.
we were, Fira as a company was the first to do it.
I have an adapter if you need it.
I have a dongle over there, I think, but here's RHEL on a Chromebook. This is some Lenovo thing. I don't remember which one, but
Lenovo thing.
I don't know. I have too many Chromebooks. I can't keep track.
oh, I bonked you. I think that one will show up. Let me get a dongle.
Yeah, let me pull this up.
I will also mention that some
Yep.
Chromebooks do have legitimate SSDs in them, and I have 31 Chromebooks. These two are the only ones with actual SSDs. So it's rare, but it is a thing.
Yeah.
And yes, they're M.2 NVMe 2280 SSDs, so they're just standard.
Okay,
so
let's drag that up
move
there.
That over. So as you can see, the hardware model is cool.
Very cool.
Yeah.
Do you
it-
want to open? Can I see this?
what do you want to do?
G parted.
Oh. Oh yeah, we can show off the disk layout actually.
Yeah.
Alright, so this
where
is.
Anaconda kind of breaks us.
Yep. Yep. This
It's
is RHEL 9.
RHEL, full access to the hardware with stock firmware.
So this is what the disk layout looks like. We have this 16 megabyte partition holds Submarine, the bootloader. This is just the standard. What is this? This is grab. This is the standard boot partition here. Or that's EFI. That's standard
To
boot.
be fair,
There's the RHEL LVM root, and then we have some extra
I
space.
did have to do RHEL a little bit interestingly because XFS, I wanted to play with XFS. But I had to put the Submarine partition on here first, and then reboot back into RHEL and go into Anaconda, and then do a custom
Do
partition
you have
layout.
fetch on here?
And Anaconda requires you to have certain partitions to actually install, even if you're doing a manual installation. So it looks a little bit different, or it will look a little bit different on Chromebook Edition, but it's relatively the same.
Yeah, we're not gonna have an EFI partition or anything. Are you getting the picture of the RHEL Chromebook? We have another one here. We have RHEL on 2 of them now. I think we're the first to do this generally.
Yeah.
Also, shameless plug again. I was the first person to put Universal Blue on a stock firmware Chromebook, and the cool thing about that is that it's immutable. So installing it was a little bit interesting, and I did it at scale, and it took me about 7 hours to figure out how to do it.
But the great thing about RPM OS tree is that it uses a grub hack to work at all, or the great thing about Submarine is that it uses grub. It just pulls a grub config, and so the OS tree hack that Universal Blue and we use works perfectly in Submarine. So here's another RHEL one. We're gonna do the whole boot process real quick.
You can also just press enter. to
Oh
go to
yeah,
the first
I didn't
one.
know that actually.
Oh well. No, you do.
Yeah.
That's what it was for. But you won't actually. Actually, this one may be a little different. It depends on. So I like to install. So we don't have a working Ultramarine Chromebook image yet. So I install Ultramarine to all my Chromebooks manually. But this may work.
We used to-
Sometimes you can use ISOs with like chain loading them. Sometimes you can just use a raw image and then just put the raw image right onto the Chromebook.
I don't think I timed that, but that was a really fast boot into RHEL. You okay? Yeah. Yeah. Sure. I don't even know where the mic went.
Oh, it's here. Yeah.
Yeah.
Bleh.
Did you point out the partition flags on Submarine?
Oh yeah, there's a G. So the Chromos kernel partition isn't special at all. It's just a GPT flag, and if we have GNOME disks on here, we can even set the flag directly in here. Most Linux systems actually come with the ability to do so. It's this one. Yeah, right there. And so if we do edit partition, it's actually normally an option.
Yeah.
And you can even there's firmware and root file system options too.
You can also do it via the command line.
We didn't add any package to do that even. Were you gonna ask something?
Yes. So it's kind of backing up a little bit, but maybe So is Fira Labs a company or
Yeah.
what are okay? So it's a
We're a
for-profit
company,
company.
and we back
Okay.
Ultramarine, but we also do some for-profit endeavors to kind of fund
Okay.
Ultramarine and
We have
all
a
the
lot
other.
of other projects that we didn't touch on, but
Okay.
if we ever do like a general Fear Labs presentation, we'll talk on all that other stuff.
Okay.
I'm going to bring the mic back.
I suppose another question while we're doing the demos.
Yeah.
Yeah, hi. I'm Adam Williamson from Fedora QA, by the way. So this is a cool project. It's super awesome. I'm really impressed. A question I thought of, there were a few points in the presentation where you had the same trope, which is like, oh, the official, the Fedora tool for this is really complicated, so we kind of wrote our own thing. I'm wondering, do you have a kind of plan for the future? The reason a lot of Fedora tools are complicated, partly it's just historical cruft, but partly it's because they have to do a lot of stuff. Like, they all started out as simple tools, and then it was like, oh, now we need to do a different image. Now we need to do a different architecture, and now someone invented UEFI, so we have to handle that. So this is probably going to happen for you lot in the future. So are you going to keep building your custom tools, or when they reach a certain level of complexity, maybe you'll cut across to something more shared? Is it something you've thought about?
So obviously it's going to depend on the tool and the reason for the complexity, but we do, and there are pros and cons to, yeah, sorry. It's going to depend on the tool and the level of complexity of the tool, as well as, why it's becoming complex in the first place. We do, I'm not really sure if this is the correct term, but we do a lot of, I guess you could call it sacrificial architecture here. So after a certain while, if a tool becomes essentially too much to handle, right, we will just, in quote, sacrifice it and essentially replace it with something that's more, either something else that's third party, or we write it again. And obviously that has, pros and cons. Like, the main cons is that you're changing out your tool chain often, which we try to make that, internally we try to make that seamless for us, but, there's going to be some difficulty there. We do hope that we won't have to do that too often, though. We try to build things in a certain way. But, as a future tell.
Try to build things kind of modularly and extensively so that, like, say with Chromebooks, we just had, I think we added one feature to our image builder, and then we were able to support Chromebooks. Yeah. So we try to build in a way that we can just quickly add support for something or remove it in the future, like BIOS support in the future we might be removing. So something like that would be a relatively easy switch with the tools we have now.
And don't worry, we will keep BIOS support for a while. So.
we got a minute left on that.
Yeah, but eventually it will get phased out.
Yeah, we want to get rid of it too.
Yeah, lots of freakouts about that. We've heard that, a lot of upset about that.
I could hear the subtext in a bit of the talk earlier where you saw the Anaconda bootloader code and went,
We did. I think we were running a call at some point looking at Anaconda, and someone actually screamed.
That bootloader. But that's the thing, is it started out nice and simple, then it was like, oh, we need
Enterprise software does that a
bootloader,
lot.
Max and UEFI, and it's just horrible now.
Yeah, Anaconda with Chromebook Edition was an interesting ride. We tried to do it for a couple months, and we just Anaconda is too hard coded to do what it wants to do, and we just could not get it to.
Our initial plan was to use PostScripts, but that does not work very well.
No, yeah, and also it's a tad janky.
It works for some things, but not for that.
Not for flashing a partition.
No. The nice thing about our replacement for it, which is, as we mentioned before, ready-made, is that it's really, the installer is actually like really stupid. I don't know how familiar y'all are with like systemd repart. We use a lot of the newer systemd stuff in Ultramarine, but repart, it's pretty simple. You make like configuration files specifying partitions. You can set like file system, and then repart is we'll take those files and we'll just partition the disk as it is. MKOSI uses it for building their images, as far as I know. And the nice thing is that it's pretty performant. It's really simple, pretty bare bones. And for the actual OS installation, we just literally DD to the partition. And we want to keep these type of things like as simple as they can, so we don't have to, again, sacrifice.
And we still get some level of extensibility in the way that Anaconda does, but it's not as messy. with all the old Python code. It is Rust, so that does raise the barrier to entry for developers a little bit, but it's a little bit less messy, and I think that's a nice trade-off when it comes to an OS installer.
I'm working on getting a ready-made demos.
He's trying to show it off, but I'm not sure if it'll work today.
I don't really know what that spell is going to look like.
BIOS thing makes me laugh because we were.
I like how we had enough time that we could risk the live demo
just like
gods.
the general one.
It worked out okay.
Images and stuff. And there was one point where I was like, I don't know if I can get BIOS
No,
we are
installations to
okay.
work.
Actually, we are actually low on time.
And,
we have until 30, right?
It was
Or
funny
12:30?
because
12:25, yeah.
Baslite, which is our
So we have
gaming-focused
3 minutes
distro,
left. Do we have any
was
final questions before we have
that
to yield
sounds
the
like
room?
a feature to me.
Yeah.
Why in God's name would you let someone install me a
There.
BIOS? He's like,
Yeah,
no.
honestly, if you are
Yeah.
bootstrapping a new thing right now, it's like you just get rid of leaving it out. It's different. We have to
Yeah.
do everything, but
Yeah.
Debian's gonna have to support it
guys are
forever.
working on Chromebook stuff, is there a business?
You guys are
Yeah,
just
so our sort
I
of
just started laughing. I was
business,
just like,
so our sort of business in terms of that is to essentially take, a lot of, especially in education, right? A lot of Chromebooks are going to go end of life, and that's going to be, it's a lot of money to replace those, and it's also just a lot of e-waste, which again, I don't really like personally. So the idea is to essentially use, the stuff that we're building here as sort of, and offer it as sort of a service to extend the lifetime of these Chromebooks.
It can also give, like recently Denmark had a law passed that prevented schools from using Chromebooks anymore because of Google's data collection. We also kind of want to help schools get out of the data collection a little bit. I know there are some legal requirements in the US for schools to collect data on students, but I think there are better ways we can do that.
This also involves potential management software being developed and then server hosting problems.
But then we become Red Hat.
Yeah. But then that is another service that we can offer to schools.
Red Hat's gotta get into that business.
Yeah.
We have a
So,
quick demo of
Here is
the
the,
installer.
I think, first public demo. Of
I-
We're not sure how this looks. I think we haven't run this build yet. So.
I'm a bit worried about this.
Yeah, we actually haven't used this build yet. So.
It's not gonna install, but it
Do you need another SD card?
The UI will work.
Actually, do you need a USB?
Where is the United States?
There.
Yeah.
We're gonna add search to this list.
might need a little.
We're gonna add search to this. Don't
There'll
worry.
be search and some UI fixes, but
Yeah,
we're
the
mainly working on that.
the UI is very bare bones at the minute.
That is an interestingly difficult problem to solve, getting a sensible language list. Like, it's,
Yeah.
it's a thing.
We initially wanted to have the user pick their region and then their language, but then we realized people don't speak languages based on regions, so we went back to the drawing board and now we need a search.
That's why the Fedora welcome screen actually switches between languages until you pick. Yeah, but it's really hard. There's a whole project called Langtable, which is all about associating.
It's
and then
such
you
a
get into
mess.
politics because you have to be really careful what you call all the different Chinese.
Yeah, we have some.
Especially with countries like the
What
US
the
because
names
there's
of
so
the
many
countries
languages
are.
here.
Yeah, it's
Yeah.
all.
We
So
have
glad
some.
Fedora does all that work
Do you
for
wanna-
us.
Yeah, that's right. You can write your own story.
I believe we have like 10 or so UX issues on linear, and they all need to they're all about just fixing this and making it look a little better, right?
Here.
This is subject to change. Thank you.
That's an average.
So cool.
Will it show up immediately or do we need to go previous?
I need to go previous and that should work.
Okay, we scan.
No, we don't.
No. Well, I can just press this. It's not gonna work. And then you do Chromebook because that's the only option yet. And then you would do install.
Watch it wipe his disk.
Well, yeah, let's wipe the disk. Woo!
Do it.
It doesn't actually.
This is his primary laptop, so he could mess up his day.
It doesn't. I've tested the builds before with the current backend. It doesn't actually do anything to the disk.
This is not the current backend. No.
This is.
This is the current backend.
I have no idea where you grabbed
yeah.
this build from.
GitHub. He
It's
like
the
went to the
most
latest
recent,
action.
GitHub action.
Oh, okay.
Just found the USB stick lying around somewhere.
All right. Well, I think we have to vacate the room now for the next talk. So any like last minute questions will be out in the hall. We should pack up like quickly.
Well, thank you for coming to our talk.